Actually, let me move it a little bit. Let's see if I can make them. I'm gonna make them seasick. You'll be okay. You can move your head. Okay, here we go. So what you need to understand is we're going to draw diagrams for each of the atoms. Okay? If you look closely, you'll see that each of the boxes has a solid line and then either 1, 2, 3, or 4 dotted lines around it. Okay? The solid line represents the edge of the nucleus. Okay? So in the nucleus, we're going to write the number of protons, like this. Here's hydrogen. It has 1 proton, so we're going to put P1 in the nucleus. Okay? Then we're going to go over to helium, which has 2 protons. So we're going to write P2 in the nucleus. And you guessed it, we're going to go all up to 20. So lithium is P3, beryllium is P4, boron is P5, carbon is P6, nitrogen is P7, oxygen is P8, fluorine is P9, neon is P10, sodium P11, magnesium P12, aluminum P13, silicon P14, phosphorus P15, sulfur P16, fluorine P17, argon P18, potassium P19, and calcium P20. Okay? Now, that's what the solid line is. It represents the edge of the nucleus. Okay? Outside of the nucleus, you'll see 1, 2, 3, or 4 dotted lines. Those represent the shells. Okay? Notice this first row has 1 shell. Second row has 2 shells. Third row has 3 shells. 1, 2, 3. Fourth row has 4 shells. Every time you go down a row, you add a shell, which is true of the table in general. Okay? Remember, the shells are the layers where the electrons spin around, correct? Like floors in a hotel building almost. Okay? But each floor or shell has a rule. It can only hold a certain number of electrons. And quite frankly, they do not make sense. So you've got to memorize them. Okay? The first shell, off to the side, you're going to write first shell. The first shell can hold a maximum of 2 electrons. If you have an atom that needs more than 2 electrons, you have to fill the first shell or the first floor first and then go on to the second. Okay? So let me show you what I mean by that. Over here with hydrogen. Hydrogen has 1 proton, so we're only going to draw 1 electron right here. Put 1 dot for electron on your first shell. Then we're going to go over to helium. Helium has 2 protons, so it needs 2 electrons. 1, 2. Now, let's go on to lithium. Well, lithium has 3 protons, so it needs 3 electrons. You have to start by filling the first shell first. So 1, 2, but I need 3, which is why we add a second shell. So it has 2 in the first and 1 in the second. Now, see if you can catch the pattern. Here's beryllium. 2 in the first, 1, 2, 3, 4. Now, look at this. The second shell can hold 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons. Now, that's after the first shell has its 2. Okay? So, let's go over here to boron. I know I'm zooming in and out a lot, but I'm trying to make it as clear as I can for the video. Okay? So, here's boron. Start with, we need 5 total. So, we have 1, 2 in the first, and then 3, 4, 5 in the second. I would do them like mine only because it will make more sense later when you see the pattern. Do it from now on. Okay. Yes.
Why are we only putting a limit of 2 in the first shell?
Because that's the rule. It cannot hold more than 2. The second shell can hold up to 8. If you got to go beyond that, you add a third shell. Okay? So here's carbon. Let's do, we need 6 electrons. So 1, 2, 3, 4, 5, 6. I'm going to keep going, but if you're still catching up, that's fine. Nitrogen needs 7 electrons. So I have 1, 2 in the first, then 3, 4, 5, 6, 7. So 2 in the first, 5 in the second, which all together gives me 7. Okay, here's oxygen. 1, 2 in the first, and then I keep going until I get up to 8. So I have 1, 2, 3, 4, 5, 6, 7, 8. Fluorine, I gotta get up to 9. So I start with my 2 in the first, then I keep going on the second one. 3, 4, 5, 6, 7, 8, 9. Now for neon, I need 10. 2 in the first, 1, 2, and then 3, 4, 5, 6, 7, 8, 9, 10. Now I have 8 electrons in the second shell, correct? So it's full. What happens when I get to sodium that needs 11 electrons instead of 10? Well, I have to add another fluor. Got to add a third shell. You see the pattern? You have to fill the first, second, however many shells first before adding more. Okay? So let's go on to sodium. Everyone got going on sodium? Okay, here's sodium. I gotta start with my first 2 in the first shell. So 1, 2. Then I keep going. How many electrons can I put in the second shell? 8. I have to have 8 in that second shell in order to have a third shell. Does that make sense? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So my third shell will only have 1. Yes. For sodium, it does hold 1. But the third shell can hold a maximum of 1, 2, 3, 4, 5, 6, 7, 8. So third shell can hold 8. After, if I need more than that, I gotta go on to the fourth shell. Yes.
So how many how is that the farthest shell can hold the amount of elements on that side for the column?
Say that again.
So for the third shell and the second shell, it holds 8.
Uh-huh.
And there were 8 elements on that.
Oh, so you're saying like this the outer shell's holding 7, outer shell's holding 6, outer shell's holding 8.
No, I meant because the second shell you said the maximum the
Correct. Except for this one,
Except for that one.
which only holds 2. Exactly.
And there were 2 on that.
Right. That's why it's set up that way.
Oh.
Every time you go to a new row, that means that shell is full, so it needs another shell. Okay? Not right. Not yet. You got to be here for this, or it will not make sense. Okay? All right. So, going on to magnesium. How many do I have to have in the first? Everyone?
2.
How about the second?
8.
There we go. That only gives me 10, though. So then I'm going to have 2 more on the last shell. So, 2 on the first. 3, 4, 5, 6, 7, 8, 9, 10. 8 on the second. And I need 2 more. 1, 2. Okay, I'm going to leave these out there, but I'm going to go on. Aluminum, 2 on the first, 8 on the second. And then 3 on the third. Silicon has 2 on the first. Then I'm going to go on to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Phosphorus, 2 on the first, 8 on the second, and then 5 on the third. Is it making, are you seeing the pattern now?
Yeah.
Okay. Silicon, 2 on the first, 8 on the second, and then 6 on the third. All right, chlorine, 2 on the first. So 1, 2. Let me go on. 3, 4, 5, 6, 7, 8, 9, 10. I go on to the third one. 11, 12, 13, 14, 15, 16, 17. You only got 3 more. Okay, here's argon. 2 on the first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay? After argon, the third shell is full. Yes?
Yes.
It can only hold a maximum of 8. It's got 8 in it. So if I need to keep adding electrons, I have to do what? That's right. Add a 4th shell. In the outer row? In the outer shell?
Oh, like, I get it now, because I didn't.
Okay?
Because I was confused. I thought you were like, oh, total. I was like, wait, no, it is 9.
Not total. Only in that shell. Now, total, there should be 18 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18.
I was confused.
Okay? Then we have our last 2. Potassium and calcium. So we got to fill all the first 3 shells first before going on to the 4th. So it's going to take some patience. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. So only one on the outside. You good, Noah? And then calcium, I need a total of 20. So 1, 2 on the first. 1, 2, 3, 4, 5, 6, 7, 8 on the second, giving me a total of 10 so far. 11, 12, 13, 14, 15, 16, 17, 18. And then my last two, 19, 20. Okay? Yes.
Oganesson must look so crazy.
Yes, I will show you oganesson actually.
It's the 180.
Now, I remember I told you though, after number 20, after calcium, the rules start to change a little bit. Okay? So normally you would think we would keep adding electrons to the fourth shell, but actually after this one, sometimes they go back and add them to the third shell. Okay? Why? I don't know. It's just the way nature is. Okay? So, but that's why we stop at 20 though, because after that things get a little more complicated. Okay? So you can see here, there's oganesson.
Oh my god. Yeah.
Okay? It has 118 protons, 118 electrons, and 177 neutrons. Okay? Okay? So there's oganesson. Let me show you. And there's hydrogen. Okay? Super teeny tiny in comparison. Okay? But look, they drew theirs just like ours. There's hydrogen, 1 proton, 1 electron. Okay? Let's see. Here's lithium. 1 proton, 2 electrons on the first, 1 on the second. Here's sodium. 2 electrons on the first, 8 on the second, 1 on the third. You see what I'm saying? Okay. We'll come back to this a little later on in our notes. Okay? You do not have to know this for your quiz tomorrow. All right? But I did want you to see, when we did our homework, we just put all the electrons on one shell, like for example, oxygen. Okay? Technically, that's not correct. But here, all I was concerned about was you having the right number of protons, neutrons, and electrons. Okay? But now you know that if you're going to draw oxygen, you really should draw it like this. 1, 2, 3, 4, 5, 6, 7, 8 protons, plus, 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 plus. 8 neutrons, 1, 2, 3, 4, 5, 6, 7, 8. And 8 electrons. But I can only have 2 on the first shell. So I need to finish it on the second shell. 1, 2, 3, 4, 5, 6. So I should have 8 total. 1, 2, 3, 4, 5, 6, 7, 8. I don't remember, to be honest. Okay. Oh, and then label, obviously. Electron, proton, and neutron. Shh, Connor. Okay? Reagan.
So whenever I did the review, I put 2 shells around oxygen,
Mm-hmm.
but I did 4 for each.